Hello again, algebra students. We're going to spend another day working with systems of equations, solving them with substitution. We started that in our last lesson, and in our last lesson, I told you that this step would be done for you. Today, that's the step that we're going to add in on most of the problems. You'll have to do some work to get one variable by itself, but luckily you already know how to do that. And then we're going to solve them just the same way that we did in the last lesson. So this first problem, actually, you already have a variable all by itself. Now, some people do get confused here, and they say, oh, the x is by itself in the second equation, and so is the y. But the y is not by itself because it has this 2 that's with it. When I say something's all by itself, that means there's nothing else there. In front of this x, there could be a 1, sure, but multiplying by 1, dividing by 1 doesn't change anything. So that's okay. This x is what's all by itself. This is going to take the place of the x. So remember, when we're doing this, when we put that in place of the x, we're going to use parentheses for our substitution. So I'll have 2, and then instead of the x, I'll put in 2y. And there's the rest of our equation. Notice the whole reason for the substitution is that now I only have y's. It's not x's and y's. I can solve this as long as they're all one kind of variable. So when I multiply the 2 times 2y, that's just 4y. And then I can combine these like terms. 4y plus 6y is 10y. And then we would divide by 10. So the y is 2. Once I know what the y is, I'm going to find the part where it says x equals, because I still have to find the x. So I want to know what x equals. X equals 2 times, well, instead of a y, I'm going to write down what the y was, which was a 2. So that means that x equals 4. When I write my ordered pair, remember, it's always, always, always x and then y. So this ordered pair would be 4 for the x and 2 for the y. We could check this by substituting into the other equation. So I would have 2 times 4, which is 8, and then 6 times 2 is 12, and 8 plus 12, oh yeah, that is 20. That works. This is now one of them where we have to get a variable by itself. And it might be confusing for some students to decide which equation to pick and which variable to pick. If there's a variable that doesn't have a number in front of it, like the y's in both equations, I'm going to pick a y. I would honestly pick the y in the first equation, though, instead of the y in the second equation. You guys know that we can put a 1 right here. A 1y is the same as y, no big deal. In the second equation, though, when I do that, that's really a negative 1y. Negative 1y, that's not just y. So I would need to do some work to get rid of that negative 1. So I'm going to use this equation, and I'm going to get that y right there to be all by itself. Think about slope-intercept form. Think about how you would move that 3x that's being added to the y. I would subtract 3x. Now remember that 5 doesn't have an x. Those don't go together. This is just y equals negative 3x plus 5. So that's what the y is equal to. That's going to go in the other equation instead of that y. Now I do have to be careful. That negative 1 that I talked about right away, that's a little bit of a problem. So when I substitute in here, actually let me keep this 2-color thing going on here. I would have 2x plus negative 1, and then instead of the y, in parentheses, I'm going to say negative 3x plus 5. Equals 10. So I took the y out, I put the stuff that's equal to y in its place. Now I'm going to have to distribute that negative 1. Negative 1 times negative 3x is 3x. Negative 1 times 5 is going to be a negative 5. And these match. We can put those together to make 5x. Now I could have plus a negative 5 right there, or just minus 5. But to get rid of that negative 5, then I would add 5. So 5x equals 15, and then x is going to be 3. Now that I know the x, that's great, but I still have to finish. I have to find the y, right? Don't just stop when you get one of the variables. So if I go back to this equation right here, where the y is by itself, remember I'm looking for the y, so I want to go where it says y equals. I'll have y equals negative 3 times the x was positive 3 plus 5. So it's negative 9 plus 5 is negative 4. When I write my equation, x and then y, my ordered pair is going to be 3, negative 4. If you want to check that, now we just use the top equation really, just kind of rearranged to be able to solve for y. So we would check it in the second equation. I would have 2 times 3, let me see where I can squeeze this in. 2 times 3, that's going to be 6. And then negative 1 times negative 4 is positive 4. So 6 plus 4, oh yeah, that's equal to 10. Sorry that got kind of squished in there. Looking at this problem, hopefully you'll notice that it's very similar to the last one we did. Again, the y's don't have a number in front of them, but I would want to pick the positive y because I don't have to worry about that negative then. So to get this y by itself, to get rid of adding 4x, I would subtract 4x. And again, the 20 doesn't match that 4x. I would write this as negative 4x plus 20. That's my y. That's going to go in place of that y. So when I write that, again, don't forget this is really plus a negative 1 in front of that. I would have 2x plus negative 1 times what the y was equal to, equals negative 2. 2x plus positive 4x and a negative 20 equals negative 2. So when I put those two together, that's going to be 6x. And we would add the 20 then. Negative 2 plus 20 is going to be 18. So the x is equal to 3. And then again, when I know the x, I'm going to look for the y where it says y equals. So I'll have y equals negative 4. The x was 3, remember, plus 20. Negative 4 times 3 is going to be negative 12. Plus 20 is going to be 8. So my ordered pair, x and then y, is going to be 3, 8. If I would check that with the top equation, I would have 2 times 3, which is going to be 6, plus negative 1 times 8. So that's going to be a negative 8. 6 plus a negative 8, yep, that's negative 2. In this problem, you really have two options, and one of them is no better than the other one. In the first equation, this y does not have a number in front of it. I could easily get that y by itself. However, in the second equation, this x does not have a number in front of it. I could also easily get that x by itself. I'm going to choose the x because we do a lot of problems where the y is the one that we solve for, because you're used to it for slope-intercept form. So I want to practice a little bit more when we're finding the x. So to get rid of subtracting 2y, I would add 2y. So x equals 2y plus 9. That is my x. That's going to go in place of the x. So I don't have space next to it. I'm going to have to do that down here. 7, and then instead of x, I'm going to put in 2y plus 9, because that's what the x is equal to, plus y equals negative 2. 14y plus 63 plus y equals -2. When I combine my y's, remember this is really a 1y, so I have 15y. So I'm going to subtract 63 or add a -63. So 15y equals -65. When I divide by 15, it's going to be a negative. Now, 65 divided by 15, that works out to, one moment please, 4 1/3, -4 1/3. Because 15 times 4 is 60, so there's 5 left over, 5/15 is 1/3. So -4 1/3. And I know that some people are going to look at that and freak out a little bit, but it's still not that horrible, especially knowing that you've got a calculator that you can use. Now that I know that, I still need to find the x. If I substitute that in place of, in this equation right here, again, it's going to be really squished if I do that, so I'm going to move down here a bit. I'm going to say that x equals 2 times a -4 1/3 plus 9. Well, you could make that into an improper fraction, that'd be fine. But 2 times -4 1/3 is going to be -8 2/3 plus 9. Those are different signs, so we're going to subtract. So I get that x is 1/3. When I check this with the second equation, actually I should write my ordered pair first. Remember, x always goes first, so it's going to be 1/3 and -4 1/3. When I check this in this equation right here, I would have 1/3 minus 2 times -4 1/3. And I want to know if that's equal to 9. Because these two are going to be both negatives, that'll be a positive 8 2/3. Plus this 1/3, oh yeah, that is equal to 9. Yeah, it's kind of messy, but it still works. In this problem, I've been trying to avoid picking a variable that has a negative in front of it. But in this case, that's going to be the easiest one to get by itself. So even though that's a -1y, I'm going to pick that. We're used to doing this for slope-intercept form, so I would just get rid of the 2x first. So -1y equals -2x plus 5. And then I would have to divide. Y equals positive 2x minus 5. That's what the y is. That is going to go where the y is. So I'll have -3x plus 6 times 2x minus 5 equals -12. I have to move this over just a bit. Distributing, I'm going to get 12x minus 30. So these two together, -3 and positive 12 would be 9x. And then we would add the 30. Gives me 18. So x is 2. Now that I know that the x is 2, I can come right here where it says y equals 2 times 2 minus 5. And 4 minus 5 is equal to -1. So my ordered pair would be 2, -1. And again, checking that, especially if I would use the second equation, because I used the first equation to get what the x was, I would have 2 times 2, that's 4, and that's the -1 or plus a -1 times the y was -1, which would turn into a +1. So 4 plus 1, yep, that's equal to 5. That's what we wanted. And for our last problem, now I'm going to have to do some division besides just dividing by -1. So I would want to pick the thing that's going to be the easiest to divide by. I would not choose this y because I'm going to end up dividing everything by 3. That doesn't divide nicely by 3, and neither does that. I would also not pick the 4 in that equation because the 3 and the 17 both don't divide nicely by 4. In the first equation, if I would choose this x, I would end up dividing everything by -4, which is okay, but 2 divided by -4 is going to be a fraction. So I'm going to pick the one that's going to be the easiest. In this problem, the one that's going to be the easiest is this y. So when I get that by itself, let me rewrite that problem right here. -4x minus 2y equals -2. I would add 4x. So I have -2y equals 4x minus 2, and then divide. The y is equal to -2x plus 1. Now that's my y. That has to go into the other equation, the second equation, where the y is, right there. So that equation is going to be -4x plus 3 times, here's what the y was, equals -17. I've got a -6x here and a +3. And when I combine those, that's going to be -10x. And then we'll get rid of the 3. I have -10x equals -20. Oh, one moment, please. I just messed that up. Sorry about that. When let's see what I can do there. When I divide by -10, I get that x is 2. That's my x. Then I'd have to find my y. So I'd go right here, and I'd say y equals -2 times 2 plus 1. So that's -4 plus 1. Then y is -3. So my ordered pair would be 2, -3. So today's worksheet is day 2 of solving systems by substitution. The answer keys in Schoology. If you have any questions, make sure that you ask. When you're all done and you check it, make sure that you take the formative. Let me know if you need any help.